Today we're doing intersection of polar graphs. In calculus, we're going to need to know how to find the intersection of two polar curves so that we can do things with it. In calculus, we're going to be finding the areas inside of these things. And sometimes we'll have two polar curves and we'll need to find like the common interior area or the area inside of one but outside of the other. And to do those, the first step is always to find the intersection of the polar curves. So these two curves intersect twice at two different theta values. So this theta value, we want to find that, and we want to find this one. What I'm going to encourage you to do is to find the value of one and use symmetry to get the value of the other. You're going to be told the values of theta, the interval that you want to find the value of theta in. Otherwise, there are an infinite number of possible answers here, right? So we're going to just have those two answers. All right, in this first example, we want to find the intersection of these two curves, and they intersect where their r values are equal. Right here, the r value of this curve is equal to the r value of that curve, so we're going to find out where those two r values are equal. So we're going to set these two equations equal to each other. So 5 cosine theta is equal to 2 plus cosine theta. Okay, solve this. I'm going to subtract cosine theta on both sides, and then I'm going to divide by 4, and we get cosine of theta is 1/2. Well, in the first quadrant, cosine of theta is 1/2 at pi over 3. And in the fourth quadrant, that would make that, using symmetry or using what we know about cosine of theta, it is also 1/2 at 5 pi over 3. And remember, our answers are going to be in here. So I don't want to use, I could have used negative pi over 3 as well, right? But that would fall outside of our boundaries. So we want to make sure that we obey what we're being told to do. So these would be the two theta, the two values of theta where these two graphs intersect. Let's do another one. So once again, we're going to find the values of theta between 0 and 2 pi where the two curves intersect. So they intersect here and here, right? So we are finding this theta value and that theta value, okay? So 4 plus 4 sine theta, we're going to set that equal to 2. I'm going to subtract 4 on both sides and then divide both sides by 4. We get sine of theta is negative 1/2. Sine of theta is negative 1/2 at when theta is 7 pi over 6 and 11 pi over 6. Easy peasy, right? Just what we did with our study on just plain trig functions. Alrighty, this one, we want to find the values of theta between 0 and 2 pi where the graph of r is equal to 8 cosine of 2 theta is equal to, intersects the graph of r is equal to 4. So how many times, how many places do they intersect? Well, they intersect at 1, 2, 3, 4, 5, 6, 7, and 8. 8 places. I'm going to find this first angle. I'm going to find this first theta value, and then I'm going to use symmetry to get the remaining theta values. Okay? So I'm going to take 8 cosine of 2 theta is equal to 4. Divide both sides by 8. Okay? The angle that makes cosine a half, the angle that makes cosine a half That first one would be pi over 3. I only care about that first one because I'm going to use symmetry to get the remaining values. Okay? If I divide both sides by 2, this is just what we did in our trig unit. Divide both sides by 2 and we get pi over 6. So this first theta value is pi over 6. Right? So using symmetry, what must be the remaining theta values? Okay? This one will be pi over 6. Do you agree that, let me get a little highlighter out. This half of the petal is the same as this half of the petal, right? That means that this theta value is the same as pi over 6 taken away from pi over 2. That will be pi over 3. So we're going to have pi over 6 and pi over 3. This one would be 2 pi over 3. This would be 5 pi over 6. Here's 7 pi over 6. 4 pi over 3. 5 pi over 3. And lastly, 11 pi over 6. Those are all theta values, 8 values where those two curves intersect. Okay, this next example, they say it is calculator active. So let's find out what happens with this. This must be one where to answer the question we need to have a calculator. All right, so same thing, we're finding the values of theta where this curve intersects this curve. I can see where it is. I can see where they are. There and there, right? We're going to find the first one, and then we're going to use symmetry. Okay, 3 minus 2 cosine theta is equal to 5 plus cosine theta. Okay, I'm going to add 2 cosine theta to both sides, and I'm going to subtract 5 on both sides. So this gives me that cosine of theta is negative 2/3. Well, we don't know an angle whose cosine value is negative 2/3. So theta is arc cosine or inverse cosine of negative 2/3. That would be in the second quadrant. Second quadrant. So that gives us this angle right here. This angle is arc cosine of negative 2/3. So what is this angle? I'm using symmetry. If this is arc cosine of negative 2/3, then what is this? That would be 2 pi minus arc cosine of negative 2/3. That's what I mean about using symmetry. So our two theta values are arc cosine of negative 2/3 and 2 pi minus arc cosine of negative 2/3. And they tell me to get this as a decimal, so I will. Go to my calculator. Okay, arc cosine, second cosine, arc cosine of negative 2/3. This should be in quadrant 2. That is a little less than pi, so yes, that's in quadrant 2. So this is 2.30. They tell me to go to at least 3 places after the decimal point, so I can just go to 3 places if you want to. The next value is a 5, so I could have made that a 1 if I prefer. Remember that you can truncate, which means just write the first 3 you see, or you can round it if the next digit is 5 or higher. Either one. I'm just going to truncate. And then we'll have 2 pi minus that value. I'm just going to scroll up, grab it, 3.982. First 3 you see. Works for me and AP. Okay? There's another one like that. Finding the 2 theta values where they intersect. So I can see them. The one's right here, one's right there. Need to find those. I'm going to find the first one, and then I'll use symmetry to get the next. All right. Still in 0 to 2 pi. 5 minus 2 sine theta is equal to 2 plus 3 sine theta. I'm going to add 2 sine theta to both sides, subtract 2 from both sides, and we get that sine of theta is 3/5. Well, we don't know an angle that makes sine 3/5. So theta is arc sine of 3/5, and that is going to give me the first quadrant angle. So this angle is arc sine of 3/5. So what is this angle? What would this angle be then? Well, to get that angle, I'm going to take pi and subtract arc sine of 3/5. If this is arc sine of 3/5, then this is pi minus arc sine of 3/5 because of the symmetry. This is equal to this, yeah? And now we'll go to our calculator as the very, very last step to get our answer. So arc sine, well, our answer as a decimal. We already have our answer, but as a decimal, 0.643, that's in quadrant 1. Pi minus that value, is 2.498, and that is indeed in quadrant 2. It's a little less than pi. Alrighty, one more. No calculator this time. Okay, the graph of r is equal to 3 minus 6 sine theta is shown below. Determine the values of theta between 0 and 2 pi where the graph is at the origin. At the origin. At the origin. Well, how many times is this graph at the origin between 0 and 2 pi? When theta is 0, sine of 0 is 0, 3 minus 0 is 0. When theta is 0, we're out here at 3. So this is kind of our starting point. As sine, as we go around, where is our curve going to be? Well, as we go around in quadrant 1, we're going to be going this way. We're going to hit 0 once as it goes around this way, and then we're going to hit 0 a second time as it goes around the loop. Remember that these are no bouncy bounces. These are all nice and smooth, right? So it hits 0 here, and then it hits 0 again, so we should have 2 answers. What is happening each time that we are at the origin? Well, at the origin, r is 0. So we're actually finding out the intersection of this curve and r is equal to 0. Setting that curve equal to 0. We can subtract 3 on both sides, divide both sides by 6. Sine of theta is a half. What values of theta make sine a half in this interval? Pi over 6 and 5 pi over 6. Those are those 2 values that we knew to expect. And that's it. Finding the intersection of polar curves.